Okay, what we're going to work on today is our last stack up example, and that's going to be for spring deflection. Now, if I look on the picture that I have here, I've got the assembly and I've got my dimensions that I need. Now, there are 4 parts that are in this assembly. There is a bearing block that's here, okay, which is the dimensions are located there on that side. There is the shaft, and it's got this big shoulder that's here. There's the spring itself, which you can see is represented by the circles. Because if I were to cut a section of a spring, I would basically be cutting through the coils. So that's where I see these circles here. And then these little squares are basically the cross section of a washer. So I've got my spring and my washer dimensions over here. I've got my spindle or my shaft dimensions and my bearing block dimensions here. Now, when we set this up, a spring stack up is a little bit different from other stack ups because it's going to start and end in the same location. Because with a spring stack up, what we're trying to find out here is how much the spring is going to change in length. And the reason we might need that is because we might need to do spring calculations. So with this assembly that I have, I'm going to mark one side of my spring. It doesn't really matter which side you start with, but we're going to start with this side. And we're going to go ahead and put our arrows in for our orientation. Always a good idea to do that. And the first dimension that's going to be in my stack up is going to be the spring free length. That is always going to be negative because we want to figure out how much smaller it's going to get. So that's going to dictate that my negative is here and that my positive is there. Okay? So now with that, I can begin my stack up. The very first dimension is my spring free length. So I'm going to go ahead and put that in there, the 50.5 plus or minus 0.2. And you can see I already have my stack up outlined in Excel for us. So we're going to go ahead and put that dimension in, the 50.5 plus or minus 0.2. And I'm going to call that my spring free length. That would be the length of the spring if it were not engaged in anything. And that is always going to be negative. I'll go back to my picture, and once I get to that, the back end of that spring is going to be engaged with the washer. So that washer that's the next dimension that I need. I need the thickness of that washer. And right here, it's 1.5 millimeters plus or minus 0.04. So that will be my second dimension. And we're going in that same direction from here to there. So we are basically traveling in the negative direction still. So that dimension will also be negative. So I'll go ahead and put that in, 1.5 plus or minus 0.04. And I'm going to say washer thickness. And I'll put my negative orientation in there. Going back to my picture, the other side of my washer is touching the spindle. Now the spindle is also touching the block. So in actuality, since that part, there's 3 parts touching. There is the washer touching that edge. I do not have to go back and figure out this thickness, so I don't really need any dimensions on that part, which sometimes this does happen because this part is also touching the block. And I eventually want to get back to this edge on the block so I can move directly to the block. Now I'm trying to get, my end point is going to be this edge here. But in order to do that, right now at the edge of the washer and the edge of the shaft, I'm here. So this will be the next dimension in my stack up. So I'm going to go ahead, I'm going to clear my marks here, and I'm going to put that dimension in my stack up next, the 1.5 plus or minus 0.1. So I'll do the 1.5 plus or minus 0.1, and that is my bearing block groove depth. And I am also moving, going back to the picture, I'm also moving in that negative direction. I'm going from this edge to that edge, okay? So I'm going to make sure I put that negative dimension in there. Now going back to my picture, if I'm taking a look at my bearing block, I'm now at this edge, and I want to eventually get to this edge, but before I can do that, I have to go to that edge. My dimension from here to there is the 28 plus or minus 0.2. So that is going to be the next dimension in my stack up. And I'm going to say bearing block mid length. Sometimes we have to be creative in the names that we use to describe what they are. Now finally, I'm going from here to there, so that means I'm moving in the positive direction. I'm going from the left to the right. So I can go ahead and make that a positive orientation. So that's where I'm going to put my plus sign here. Going back to my picture, looking at my bearing block, I can finally go from this surface to that surface, and that will be my last dimension. That's that 1.5 plus or minus 0.2, and I'll be finally touching the spring again at that point, so that's where I know I'm going to finish. And that is also in the negative direction. So I'm going to go ahead and add that last dimension in. Bearing block thickness. Okay, and that is in the negative direction. Now, since I have all my dimensions, my next step, I'm going to go ahead and put my underline here. That way I know the next line is going to be my operations. And as usual, this is where the pluses and minuses are going to help us. We are going to always type in Excel equals in our Excel cell to do a calculation. And I'm going to pay attention to my minuses and pluses before I touch these cells to put them into the operation. So since there's a minus there, I'm going to type in minus and then touch that 50.5. I've got a minus in this row before I touch that cell. I've got a minus in that row before I touch this one. Then I've got a plus for this 28, then a minus for this 1.5, and then I can hit enter, and there's my calculation. So this spring deflection stack up, this tells me how much the spring deflects, and that is 27 millimeters. That's going to be necessary to do some spring force calculations. Now, before I do anything, I'm not finished because I've got to account for all my tolerances. And we've got five dimensions in this, so we know that's not greater than 7, so we won't have to worry about a statistical. But let's go ahead and calculate our overall tolerance. And that's going to be equals, and then we're going to add them all together, so I'm just going to use the sum. I'm going to highlight all my numbers, close it, and there's my total. So I can say spring deflection for the bearing block. Okay. Now, since I've got these two here, I might want to find the minimum deflection and the maximum deflection. So we can go ahead and calculate that. Minimum deflection, maximum deflection. Okay, now my minimum deflection is going to be the smaller negative number. So that's going to be this number plus that number. Okay, since it's already negative, I want the lower negative number for my minimum deflection. So I'm going to go ahead and say equals, click on this cell, and add this one here. Okay, now the reason why I'm making a special point about this is before, when we do the minimum, we take this number minus that one. But since this one is negative to start with, to get the minimum deflection, the minimum negative number, I have to add it instead of subtract it. For the maximum deflection, I want the larger negative number. So that's why I'm going to take this one now and then subtract that one, and that will give me a larger negative number. So I'm going to say equals, start off with my nominal value, and then I'm going to subtract my tolerance, and that's going to give me the maximum possible deflection. And there we go. That is our spring stack up.